Hello everyone, welcome to my channel. Okay, so today we'll discuss about two-port networks. It is a very important topic in networks. Okay, so let us consider a two-port network model. Okay, if you consider any electronic system or communication system that is look like a two-port network model. If you consider an electronic circuit or a communication system, it consists of a network or the circuit. Okay, inside that there are many components are connected in different manner. Okay, either in series or parallel, active elements or passive elements which are connected as a circuit. For this circuit, we will apply some input at a pair of terminals called a port. Okay, this is one port, one dash, two dash. This is another port. Okay. So this is called a general two-port network model. More general way, if you consider a two-port network, that will be look like this. At the input terminals, we'll apply some voltage as the input. Okay, this is V1, and the polarity should be given like this, plus minus, and it will deliver some current I1. It will deliver some current I1. So in a similar fashion, at the output, okay, if you connect a load, or in the two-port network model, here also if you connect a source, it will deliver the current I2. If this is a load, then current will be flow in the opposite direction. Okay, so IL will flow in this direction. IL, if it is a load current, that will be flows in this direction. Okay, that is IL. So this is the general two-port network model. Okay, whatever the currents will consider, this is I1 and this is I2. Okay, and this is V2. So this is the general two-port network model. So in a two-port network, V1, I1 are the input voltage and currents, and V2, I2 are output voltage and current. Okay, so these are called variables. V1, I1, V2, I2 are called variables. Network variables. In general, we will call it as network variables. Network variables are four. That is V1, I1, V2, I2. Okay. In a two-port network, what are the parameters? Parameters are nothing but, for a given two-port network, parameters remain same. For a given two-port network. Whatever the value of the variables are V1, I1, V2, I2. Whatever the value of the variable, parameters always remain same. Okay. So parameters, how many parameters are exist for a given two-port network means taking two parameters as independent variables, taking two parameters as independent variables, and another two are considered as dependent variables. Okay, so in this fashion, among four variables, we'll consider two as dependent variables, another two as independent variables. So there exists 4C2 combinations. These many parameters that are exist. 4C2 means we know that 4 into 3 divided by 2 into 1. So this value is 6. So 6 parameters are exist for a given two-port network. These parameters are remain same, okay, for a given two-port network until unless if you change this entire network elements, even if you change one of the element value, then all the parameters will be gets changed. Until unless we are not changing this network, we are not changing this network elements. Okay. So parameters are remain same. What are the parameters of a two-port network are? There are open circuit impedance parameters called Z parameters, short circuit admittance parameters that are Y parameters, transmission parameters called as ABCD parameters, H parameters, hybrid parameters or H parameters. These are the four important parameters of a given two-port network. What are the other two parameters? Other two parameters are inverse ABCD parameters, and inverse H parameters. This dash represents inverse. The parameters are inverse parameters A dash, B dash, C dash, D dash of a transmission parameters, inverse ABCD parameters, inverse H parameters. So these are the 6 different parameters that are exist for a given two-port network. Okay, now let us go in detail how to determine these parameters for a given two-port network. Okay, first let us see Z parameters. Let us see Z parameters. Z parameters. Okay, any parameter is described by two equations, set of equations. Any parameter Z, Y, A, B, C, D and H parameters are governed by set of two equations. Okay. For Z parameters, what are the equations are the dependent variables for a Z parameters of a two-port network are V1, V2 are dependent variables. Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. These are the set of equations that represents Z parameters of a two-port network. Here, what are the parameters are Z11, Z12, Z21 and Z22. Okay, these four are called Z parameters. And in the matrix form, these parameters can be represented in 2 by 2 matrix as Z11, Z12, Z21 and Z22. Okay, these are the Z parameter representation in matrix form as a 2 by 2 matrix. Okay, now let us represent individual Z parameters. What is Z11? How we can get Z11 of a given circuit or the network, given network. So if you observe the equation 1, in the equation 1, if I2 is 0, we can get Z11. Z11 as V1 by I1. Okay, when we can get Z11 as V1 by I1 means if I2 is 0. Okay, remember V1, V2, I1, I2 are the variables. We can vary those values. Whereas Z11, Z12, Z21 and Z22, these are fixed values or parameters are remain same for a given two-port network. We cannot change those values. So what we can do, only thing is we can make I2 as 0. If you make I2 as 0, then we can determine Z11 as V1 by I1 when I2 is 0. Similarly, this one when I2 is 0, in this second equation, what is Z21? Z21 is V2 by I1. V2 by I1 with I2 0. Okay. These are the two parameters. Two parameters out of 4 Z parameters. Similarly, when we can get Z12 when I1 is 0. When I1 is 0, we can get Z12. What is the expression? This is V1 by I2 with I1 0. With I1 0. Similarly, Z22. What is Z22? V2 by I2. V2 by I2 with I1 0. Okay. For a given two-port network, okay, always we consider two-port network model, okay, as this is one port. Pair of terminals represents a port. This is another port, output port. So here we'll represent input voltage as V1, input current is I1, this current is I2, this voltage is V2. Okay. Now see this one, what is I1, I2 0? I2 0 means we'll make output terminals as open circuit. What is the condition I1 0? If you make input terminals as open circuited, then we can get these parameters Z12 and Z22. Okay, these are the Z parameters of a given two-port network. Okay, so these are the set of equations that governs the Z parameters. Here V1, V2 are the dependent variables. I1, I2 are independent variables. I1, I2 are independent variables. Okay. Now let us see the other parameters. The second parameters are Y parameters. Y parameters. Here also, Y parameters are also called short circuit admittance parameters, whereas Z parameters are called open circuit impedance parameters. Why these are named as open circuit impedance parameters means while finding Z11 and Z21, what we are doing? We are making I2 as 0. So I2 output is open circuited. While finding Z12 and Z22, we are making I1 as 0. Okay, the input terminals are open circuited. Every time to find any of the Z parameter, we need to open circuit one of the port. Okay, so these are called open circuit impedance parameters. Why it is called impedance means voltage divided by current. So units are impedance. Voltage divided by current. According to Ohm's law, the units are ohms. Now coming to this Y parameters of a given two-port network. So Y parameters are represented by the set of equations by considering I1 as dependent variable, I2 as another dependent variable. What is I1 is Y11 V1 plus Y12 V2. Y21 V1 plus Y22 V2. These are the set of equations that governs Y parameters of a given two-port network. Similar to Z parameters, the individual Y parameters are represented as Y11 is when V2 0, when this V2 is 0, Y11 is I1 by V1, I1 by V1 with V2 0. Similarly, Y21 is I2 by V1 with V2 0. Okay. Y12 is, to find Y12 and Y22, we need to make V1 as 0. We need to make V1 as 0. So what is Y12? I1 by V2. What is Y22? I2 by V2. So these are called short circuit admittance parameters. Why? Because to find any of the Y parameter, we need to make either V1 as 0 or V2 as 0. So voltage is 0 means we are short circuiting the one of the port. Okay. So these are the individual Y parameters, and these Y parameters are also represented in the form of 2 by 2 matrix Y11, Y12, Y21 and Y22. Okay. So these are the Y parameters of a given two-port network. So these parameters are also represented in the circuit form like this. These are short circuit admittance parameters, also represented in the form of two-port network model. So this is admittance Y11, Y11, V1. This voltage is V1. This current is I1. So this is Y1 to V2. This is dependent current source represented like this. Y1 to this V2. This depends on output voltage V2. The reason why it is a dependent current source. This is current, right? I1 equal to Y11 V1. This is Y11 is the admittance multiplied by I1. Similarly, Y12 multiplied by V2. This represents current value, right? So we have represented current source. Similarly, the second equation also represented as the dependent current source. That value is Y21 V1. This is Y21 V1. The output admittance is represented by Y22. This is Y22. Here is the entering current I2. Here is the entering current I2. So what is the current that is flowing through this Y22 is simply this voltage is V2. This voltage is V2. So this current is nothing but Y22 V2 plus Y21 V1. So this is the circuit model representation of Y parameters. Similarly, Z parameters. Z parameters are represented by these equations. This is one. So V1 equal to, here is the impedance Z11. This is Z11. The entering current is I1. Z11 I1 plus the dependent source. This is dependent voltage source. Dependent voltage source. So this is dependent voltage source. That value is Z12 I2. This depends on output current. So this is represented as dependent voltage source. Similarly, this voltage in the output expression, this also dependent voltage source that depends on current I1. So this is Z21 I1 and this impedance is Z22. This impedance is Z22. So this is how we can represent the two-port network equations in the circuit form. Okay, this is very important in analyzing any of the circuits. So these are the Y parameters. And now coming to the transmission parameters, those are ABCD parameters. ABCD parameters. Like Z parameters and Y parameters, the ABCD parameters are also represented by set of equations V1, taking V1 and I1 as dependent variables, and V2 and I2 as independent variables. So here V1 and I1, ABCD parameters are also called transmission parameters. Transmission means if you consider the current from the power plant, the power is distributed from the power plant to substations. So the power is transmitted by means of transmission lines. Transmission lines. So the transmitted power or the transmitted voltage and current are expressed in terms of these transmission parameters ABCD. Okay, the reason why this set of equations or the parameters ABCD are called transmission parameters. So this is equation 1 and this is equation 2. Now the individual parameters, ABCD parameters can be obtained. If we make I2 as 0, we can get A and C. What is A? This is V1 by V2. V1 by V2 with I2 0. With I2 0. Similarly, what is C? I1 by V2 with I2 0. What is B? B is minus V1 by I2. If you make this V2 as 0, what we'll get? V1 is minus BI2. So what is B? Minus V1 by I2 with V2 0. Similarly, what is D? D is, if you put V2 as 0, we get I1 equal to minus DI2. So minus I1 by I2. Minus I1 by I2 with voltage V2 0. Like voltage V2 0. These are the individual ABCD parameters, and these ABCD parameters are also represented in the matrix form A, B, C, D, like this 2 by 2 matrix form. So this also represented. Okay, these are the transmission parameters. And coming to the H parameters, coming to this hybrid parameters. Hybrid parameters are very useful in analyzing transistor circuits, mainly bipolar junction transistors. Why? Because this parameter model or the set of equations for this hybrid parameters is nothing but V1 and I2 are taken as dependent variables, and H11 I1 plus H12 V2, H21 I1 plus H22 V2. So why these hybrid parameters are useful in analyzing the bipolar junction transistors means bipolar junction transistors are mainly current controlled devices. So if you apply at the input, if you apply some voltage, there will be some change in the current, output current. The reason why the BJT is called current controlled devices. We know that FET are voltage controlled devices. So individual H parameters can be represented as H11. To find H11 and H21, we need to put V2 as 0. So what is H11? V1 by I1 with V2 0. What is H21? I2 by I1. I2 by I1 with V2 0. What is H12? H12 is V1 by V2 with I1 0. If we make this I1 0, we'll get H12 as V1 by V2 with I1 0. What is H22? H22 is I2 by V2. I2 by V2 with I1 0. Okay, these are the individual H parameters. H parameters are also represented in the matrix form H11, H12, H21, H22. Okay, so we can represent this H parameter model in the matrix form, sorry, in the circuit representation. So these two equations can be represented in circuit form. So if you observe this H11, this is V1 by I1. V1 by I1. So this is impedance. This is like impedance. This is H11 plus. If you observe this, this is voltage. V1 is voltage. Voltage is represented as H1 to V2. So this is dependent voltage source. This is dependent voltage source. This is plus minus H1 to V2. H1 to V2. The input voltage is V1. The input current is I1. Similarly, the output will represent, this is current, I2 is current, this H21 I1. I1 is the current in the input. So this is dependent current source value, that is represented like this. Dependent current source represented as H21 I1. H21 I1. And this is, if you observe H22, this is admittance value, right? I2 by V2. So we'll represent in the parallel path. Admittance is represented in parallel path, that is Y22. So here output voltage and currents are, this is I2 and this is V2. This is V2. So this is the circuit representation of hybrid parameters. Okay, so in today's class, we have learned about the network parameters and other two parameters, inverse ABCD and inverse H parameters are of less interest in circuit analysis or in the network analysis. Okay, we don't much focus on these ABCD parameters, A dash, inverse ABCD, C dash, D dash. What is the inverse ABCD parameters are? Here V2 and I2 are represented in terms of V1, I1, A dash V1 minus B dash I1, C dash V1 minus D dash I1. These are inverse ABCD parameter equations. Inverse H parameter equations are, previously we have taken V1 as input voltage and I2. So here we will consider in the reverse fashion as in the H parameters, we have considered V1 and I2 as dependent variables. Okay, so we have V2 and I1. Okay, first we'll write I1 and then V2. Okay. So here I1 is H11 dash V1 as H12 dash I2. H21 dash V1 plus H22 dash I2. Okay. So these are the inverse ABCD and inverse H parameters. There is Now, not much interest on these inverse parameters. So we'll mainly focus on these four parameters: Z, Y, ABCD, and H parameters. Thank you. In the next class, we'll solve the parameters of a given two-port network. Thank you for watching.